Hello, my name is Zhenyue Qin. I am here to present our work, Informative Class Activation Map. This is a joint work by other two authors, Dongwoo Kim and Tom Gideon, from both Australian National University and Postech. Our motivation originates from class activation maps, proposed by Professor Boley Zhou et al., abbreviated as CAM. CAM helps people understand CNNs focus on which regions to predict the corresponding label. For example, as the finger indicates, the redder regions of the image mask indicate more focus of the CNN. In order to recognize the input image as the Australian Terrier, the CNN put much more emphasis on the dog rather than the human and other background. Intuitively, the region with high CAM values are expected to have large information about the label. However, we aim to quantify how much information does each partial region of the image has toward a particular label. In order to quantify the information of each region contains for a label, we first briefly introduce our other work in this workshop called Neural Network as Mutual Information Estimator. In that work, we show if the dataset is balanced, the neural network classifier is a mutual information evaluator. In this way, we can bridge neural network classifiers and Shannon's information theory. Mutual information is the expectation of pointwise mutual information. Intuitively, as the finger indicates, pointwise mutual information evaluates the mutual information quantity between a single image and a label. Pointwise mutual information still measures the information relationship between the entire image and the label. We aim to know what is the quantitative information relationship between a part of the image and the label. So as we have illustrated in this slide, we desire to know the information quantity of the partial middle box towards the label cat. In order to decompose the pointwise mutual information between the entire image and the label to different smaller regions, we discover a trick. As the first equation shows, the pointwise mutual information consists of two terms. The first term can be expanded as the formula of CAM. Therefore, we can decompose that part into the sum of different regions. However, for the second term, that is, the log sum exponential part, we cannot decompose it. Hence, we do a trick like in the second equation to remove the second term. As one can see, the second term has been cancelled out. We call the result of this subtraction as Informative Class Activation Map, abbreviated as InfoCAM. We choose this name because this new metric connects CAM with Shannon's information theory. So as this image depicts, we can finally quantify the information between a region of an image and a label. Let us see some exponential performance. In the original CAM paper, the authors had the weakly supervised object localization task. Specifically, as the finger shows, given a neural network classifier, we localize the object corresponding to the label. This slide displays some qualitative results for localizing single objects. As we can see in the left finger, InfoCAM can localize the objects more precisely than the original CAM. For the previous CAM, the bounding boxes don't tightly surround the objects. In the right finger, we can see that InfoCAM focuses on the entire object instead of just concentrating on a part. InfoCAM can also localize a single object among multiple objects. Here, we aim to extract all the digit 0. We see that InfoCAM can accurately pick all zeros. The generated results are sharp and clear. In contrast, CAM gets confused by some parts of the digits that look like zeros, and the results are blurry. We have released our paper and source code. They are available through scanning these two QR codes. Thank you for listening.